Hello, what I'd like to do today is spend a little bit of time talking to you about this oscilloscope, which you're going to be using in a lot of your labs. So look, let's get a little bit closer so that I can actually explain to you how this guy works. Okay, the first thing is to really figure out how we actually turn the scope on. So if you look here, there's a button here. It's at the bottom left corner, and that is our power button. So if we press this button here, we should turn the scope on. All right, now what it's going to do is it's going to do all its self-testing and all its initialization, and this could take, I don't know, it might take 60 seconds or so. All right, this is the self-test completing. And we're going to basically push menu off. There's a menu off button there. So if you had something on the screen you didn't want, you could press that menu off button. Now what we're seeing here basically are 4 channels. So we've got channel 1, 2, 3, and 4. Now for our purposes in this little demonstration, I really only want one channel there. So I'm going to go over here and have a look at my channels. Okay, so we've got 1, 2, 3, 4 channel inputs here. We're going to just use channel 1. Okay, so let's go to channel 2. Here's the button for channel 2. It's marked blue, corresponding to our blue trace that we have over here. If I press this guy and just press it once, okay, and then once again, it disappears. If I want to bring it back, I just press the button once and it comes back. So once again, to make it go away, I just press it and it goes away. So let's go to channel 3. We want to get rid of this. So we'll press this guy. That's selected channel 3. And then we're going to press it once again and it's gone. Let's get rid of channel 4. So we're going to press the channel 4 button here. We're going to press it once to select the channel 4. And then we're going to press it once again and it's going to disappear. So now here we sit basically with just that channel 1. What I'm going to do now is take this lead, which is connected to this signal generator. Now this signal generator is producing a sine wave, and I'm going to connect this lead to channel 1 like so. All right, so what you have here, what you can see, is basically a sine wave, but it's not stable. It appears to be running across the screen of the scope. What we need to do is we need to trigger this. Now triggering is really a process of producing a stable trace. So look, if you come over to here, have a look at this side of our scope over here, you can see there is a section called trigger. There's a little button there called menu. So what we're going to do is we're going to simply press that button. This brings up a menu. Now there are a number of things that we can consider here, but look, the most important one initially is to look at the source. At the moment, we are actually trying to trigger on source number 3. It's a signal coming in on channel number 3. Well, have a look at this. There's actually nothing connected here. And so what we really need to do is change our source of triggering. So to do this, we're simply going to press the button that's beneath our source designator in the menu. So we'll press it like this. This brings up another little menu here. And as you can see, again, we are triggering or trying to trigger on a signal coming in on source or channel 3. Okay, so to change this, I simply go over to this knob over here called multi-purpose. I'm going to simply rotate this guy. So I'm going to rotate it up, okay, and then up once again so that I'm actually now triggering on a signal that is coming in on channel number 1. And as you can see, we actually do have a stable trace. A couple of other things to consider here. If I look at type, we are triggering on the edge of this incoming waveform. And if I go over to here and have a look at the slope, we're actually triggering on the leading edge of this incoming waveform. Now, in order to kind of get rid of our menus here, I simply go over to the menu off button. If I press that once, get rid of that menu. And if I press that once again, I can now see my sine wave there, and I've got a nice stable trace. So now let's look at the setup for channel 1. Pressing this button here brings up the menu, and this is the menu allows me to change the setup for channel 1. Okay, our first item here is coupling. Right now we're set on DC. What this means is that I'm actually displaying both the AC and DC components of that incoming signal. If I press the button under coupling, I can move that to AC. That means I'm displaying just the AC component now of that signal. If I press it again, I'm now displaying the ground or the 0 reference. Press it once again, I'm back to my original condition. All right, moving along to label. If I press this button here, this now allows me to assign a label to that particular signal if I choose to actually do that. To get rid of this, I can simply press the menu off button. All right, as far as probe setup is concerned, this is currently set to a ×1. I can press this button here, which brings up another menu. Right now, the probe type is a voltage probe. I can change that. I can change it by pressing this button over here, and I've changed it to a current type of probe. If I press it once again, I'm back to a voltage probe. All right, next item down is attenuation. And currently, this is a ×1 attenuation. I can change that by this multi-purpose knob over here, and you can see that the other way, you can see that I've got ×2, ×5, ×10, ×20, ×50, and so on. I can very quickly go back to ×1 by pressing this button here, or I can very quickly go to a ×10 by pressing this button over here. And let's take that back to a ×1. All right. Getting rid of these menus, I just press the menu off button. I now want to talk to you about scales. We'll start with the vertical scale. A little hard for you to see here, but this is divided up basically into divisions, and each division is a centimeter. Okay? Indicated by this number here, we have 2 volts. What that means is that we have 2 volts per division, or 2 volts per centimeter. I can change this scale by this knob right here. So give you an example, I'm going to rotate this. We now have 1 volt per division, and of course you see that reflected in the trace. So going back to 2 volts per division. All right, horizontally, this is time. And this number here indicates that we have 1 millisecond per division horizontally. That's 1 millisecond per centimeter. I can again change the scale here, and I change the scale by going over to this section of my scope over here, which is labeled horizontal, and I come down a little bit to this knob, which is my scale knob. And to give you an example, let me rotate this. Okay, so rotating this, you can see now that this is really what? 2 milliseconds per division. And changing again, this is 4 milliseconds per division. Of course, you see that reflected in the actual trace. So let's go back to really 1 millisecond per division. All right, now let's consider how we're going to make measurements of both amplitude and frequency. Okay, I need to turn on my measurement cursor. So you'll see there's a little button here, and above the button you see the word cursor. So all I need to do is press this button. Okay, I'm going to press it a second time. Now what we're seeing here really are 2 sets of cursors. We've got our solid lines here. Okay, these guys are used for basically making our amplitude measurement, and they're the movable cursors. And then we've got our dotted lines sitting over here, okay, and they're going to be used for making our time measurement. These guys are not movable at the moment. All right, so let's see if we can make an amplitude measurement. So we're going to move this cursor right here, okay, and we're going to move it down to this peak. All right, so I'm going to go over to my multi-purpose knob over here, which is really the A multi-purpose knob. I'm going to bring that guy on down. I'm going to bring it down to where that peak is, like so. There it is, about there. Okay, yeah, that's it. Then I'm going to move this lower cursor here to this negative going peak that you see here. And I'm going to use this knob here, which is my multi-purpose B knob. And I'm going to bring that guy on up, like so. Okay, here we go. Oh, there it is. All right, so this number over here indicates basically that amplitude, that peak-to-peak amplitude. And if you can read that, that is saying it's 8.08 volts. That is the peak-to-peak amplitude. Well, that's consistent with what we said about scales, and in particular our vertical scale, because what we have here, although hard for you to see, is we have 1, 2, 3, 4 divisions vertically between these two peaks. And at 2 volts per division, and 2 volts are 8, that's our 8 volts, which is very consistent with that number that we see over there. All right, let's see if we can make a time measurement. All right, so we need to really turn on these cursors here, or at least make these cursors movable. All right, so we go over here to that select button. Let's press our select button. Okay, these are now movable, and of course these two cursors are now fixed. So let's take this guy here and put it onto the first peak. All right, so we're going to use our multi-purpose A knob. We're going to bring it over really to that first peak like so. All right, there we go. Okay. We're going to take this cursor and we're going to move it over to this peak. And we're going to use our multi-purpose B knob to bring it on over really like so. All right, here we go. Okay. So they're roughly about there. Okay. So this period of time between these two peaks, okay, is given by this number over here, which is 5.2 milliseconds. That is the period of that sine wave. So look, as a little exercise for you guys to do, why don't you take 1 over that number, and that will of course equal the frequency. And then you can compare it to the frequency that you're seeing here on the scope of what is that? That's 191.2 hertz. All right. Now let's have a look at these other numbers that we're seeing. Okay. Let's first of all look at these numbers. Now, if you can see basically the intersection of this vertical axis and this horizontal axis here, that is what has been set up as a 0 point. So really, as it were, this cursor right here, from a time point of view, is what? If I read it here, it's actually 1.1 milliseconds from 0. This cursor over here, if I look at this cursor right here, from that 0, it's negative of that 0 by the amount of what? 4.1 milliseconds. Okay? All right. Let's look at these two numbers here. Okay? Let's look at this cursor. Once again, this is our defined 0. We're simply saying that this cursor is above that 0 by what? 4.16 volts. This cursor here is below the 0 by what? That minus 3.92 volts. I hope this gives you a basic understanding of how to use this oscilloscope. And just remember, the more you use it, the easier it becomes. I'll see you next time.